So today we will discuss about structural diagrams and their analysis to select best version. Means for structural formula, there are a number of structural diagrams can be drawn, and out of that, which diagram is most suitable, that we have to find out. So here, different structural formulas are given. For that, we have to draw the different structural diagram. So first structural formula is Z is equal to 2, 1, 3, 2 and 2, 6. Second is Z is equal to 2, 1, 3, 4, 2, 4, not 2, 4, 2, 2. Then third one, Z is equal to 2, 2, 3, 4, 2, 1. Then fourth structural formula is Z is equal to 2, 3, 3, 1, 2, 6. Next is Z is equal to 2, 6, 3, 2, 2, 1. And last one is a 2, 6, 3, 1 and 2, 3. So these are the various structural formulas are given. So we are writing this structural formula in the form of Z is equal to P1x1, P2x2 and P3x3. So here in this diagram you can observe that P1 is 2, P2 is 3 and P3 is 2. Then x1 is equal to 1, x2 is equal to P1 and x3 is equal to P1, P2. So from this we get this structural formula first. For Z is equal to 2 by 3 by 2. So this is the standard one, and there will be a 6 structural diagrams or 6 structural formula can be obtained for this Z is equal to 2 by 3 by 2. So that will be the Z is equal to 12. Okay, 2 by 3, 6, 6 by 2, 12. So Z is equal to 12 speed steps are there. So for that Z is equal to 12, we get the number of structural formula as a 6. Second structural formula 2, 1, 3, 4 and 2, 2. Similarly, we will get the different structural formula for same Z is equal to 12. Now we have to draw the structural diagram for each and every structural formula. Now this is the structural diagram for the structural formula 2, 1, 3, 2 and 2, 6. So here you can observe that number of horizontal lines equal to 12, that is nothing but equal to Z values. You can observe number of horizontal lines first, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11 and 12. So these 12 speed lines are there. As it is a 3-stage gearbox, so number of shafts are 4. So first is the input, last is the output, and shaft number second and third are the intermediate shaft. So here for first stage 2, 1, so 2 speed lines are there and spacing is equal to 1 between that 2 speed line. For second stage, for this input and for this input, there will be a 3 speed lines. So this is the first, second and third speed lines having spacing equal to 2. So this will be 1 unit and this will be second unit. So the spacing is 2. Again for these 2, spacing is 2 and lines are 3 for this input. For the second input, these are the 3 outputs, first, second and third. So that will be 3 input, 3 lines and 2 are the spacing for every input. For first, it will be like the first, second, third, and for second, first, second and third. So this is for second stage. For third stage, we have to draw the 2 rays from each input and the spacing should be a 6. So lowest ray input is N4, output will be N1 and N7. So the total stepping will be, or space will be 6. 1, 2, 3, 4, 5 and 6. For this second, N2 and N8. For this third, N3 and N9. For this, N4 and N10. And for this, N5 and N11. For this, N6 and N12. So you can observe all the nodes on the output shafts are covered from the input. So this is the structural formula for 21, 32 and 26. This is the structural diagram for structural formula 21, 32 and 26. Similarly for second 23, 31 and 26 is the structural formula. So for first stage, 2 lines and spacing is 3. So here you can observe 1, 2 and 3 is the spacing. For second, we have draw 3 lines and spacing is 1. So here from this input, we get the 3 lines and 1 spacing, and from this input, we will get the 3 lines and 1 spacing. Again, for this last stage, 2 lines and 6 spacing or 6 speed state space. So this will be the input, and N1 and N7 are the output for this first input. Similarly for this N2 and N8, for this N3 and N9, for this N4 and N10, for this N5 and N11, and for this N6 and N12 are the rails. So from this we can get the structural diagram for the structural formula 2, 3, 3, 1 and 2, 6. Similarly, next structural formula is 2, 2, 3, 4 and 2, 1. So you can draw the 2 lines and spacing is 2, 3 lines and spacing is 4. Again here 1, 2, 3 spacing is 4, 1, 2, 3 spacing is 4. And last one 2 lines and spacing is 1. So for every input there will be the 2 outputs. You can observe here all the nodes are covered in this diagram. So this is the structural diagram for the structural formula 2, 2, 3, 4 and 2, 6. Next one we have a 2, 6, 3, 2 and 2, 1. So here 2 lines from the input and 6 will be the spacing. Then 3 lines 1, 2, 3 and spacing will be the 2. For this also 3 lines and 2 spacing. And last one 2 lines and 1 spacing, means all the nodes on the output shafts are covered. So this is the structural diagram for the structural formula 2, 6, 3, 2 and 2, 1. Now select the optimum ray diagram. So one node method of optimization can be implemented to get the optimum structural diagram. So you can observe here 3 structural diagram. One is a 2, 3 and 3, 1, and second we have drawn, and third also we have drawn. So here you can draw the one table shows the column number 1 as a ray diagram 1, 2 and 3. This is the 1, 2 and 3. Then number of nodes on transmission shaft. So here lowest node we have to consider on the transmission shaft. So 3 number of transmission shafts are there: input, intermediate and output for every structural diagram. Input, intermediate and output. Input, intermediate and output. So this is a node, number of node on transmission shaft 1, number of node on transmission shaft 2, and number of node on transmission shaft 3. Then here sum of node we have to take. So we have to take the sum of this node on the transmission shaft for each ray diagram. Then we have to write the remark which one is the best. So we consider the first structural diagram for which node on the first transmission line is 1. So here we write the 1. For second shaft, lowest node is a 4. So we write here 4. And for third shaft, lowest node is a N1. So that will be the 6th node. So here we write the 6. After that, we made the sum. 1 plus 4, 5. 5 plus 6, 11. So this is for first structural diagram. Sum of node is come as a 11. For second, node on transmission shaft 1 is a 1. So here 1 for second diagram. For second shaft, it is not third, it is second. It should be second. So for second shaft, it will be the 1, 2, 3, 4 and 5. So 5 number will be right here, 5. And for last shaft, the lowest node is a 6. 1, 2, 3, 4, 5, 6. So here we write the 6. Then sum of node 5 plus 1, 6. 6 plus 6, 12. So sum of node will be 12 for second structural diagram or ray diagram. For third, node on transmission shaft 1 is 1. Here, so we write for third diagram 1. For second, 1, 2, 3, 4, 5 and 6. So for second, lowest node on the second transmission shaft is a 6. So we write here 6. And for third shaft, again lowest node is a 1. So 6, 1, 2, 3, 4, 5, 6. So we write the 6. After that, we make the sum of node 1 plus 6 that will be equal to 1 plus 6, 7, 7 plus 6, 13. So here we get the sum of node for each structural diagram or ray diagram. So first it will be 11, second one it will be 12, and for third it will be 13. So after finding out the sum of node, we have to make the conclusion that the sum of node is minimum for the diagram, which is the optimum ray diagram. So the for first diagram, sum of the node is 11. So this first diagram is called as a optimum ray diagram or optimum structural diagram. So the formula for that diagram is also considered as a optimum structural formula. So in this way, we can calculate the which diagram or which structural formula is optimum from the given structural formula or given structural diagram or given ray diagram or given speed diagram.